Okay, so we're back now. So now we're going to take a look at the right rectangular approximation method. All right. So we're still going to stick with the same function that we were using before, y equals x squared plus 1, and we're looking at the interval 0 to 4. Okay. So I'm going to draw our picture again. So here's our happy little parabola, and we're going to find the area underneath it thusly. Okay, so we're going to split it up again by 1, 2, 3, and there's 4. Okay, so we're going to use this, we're going to divide it up into 4 rectangles again. Okay, only this time we're starting from the right. All right, so our first rectangle is going to be this big guy up here. Our next rectangle is going to be this one. Then we've got this one, and then we're going to end here with this guy. All right, so again, we have 1, 2, 3, 4 rectangles. Okay, another word for the rectangle, these are called 4 subintervals. All right, using 4 subintervals. So the number of rectangles is the number of subintervals. Okay. And then this basically is the same thing that we just did before, all right? Only instead now, each of these again have a base of 1, but they still have a height of f of x. Before, when we were doing the left, we started with f of 0. We're not going to start with f of 0 this time. This time we're going to start with f of 1. So for 4 subintervals, it's going to be 1 times f of 1 plus 1 times f of 2 plus 1 times f of 3 plus 1 times f of 4. So this becomes 2 plus 5 plus 10 plus 17. So we end up with a area approximation of 34. Wow. So we went from too little, now we're doing too much. Okay. Similarly to how we fixed this problem last time, what would be better than 4 subintervals? 8 subintervals would be better. So draw another diagram. Here's what we're working with. 0, 1, 2, 3, and there's 4. So now we're going to split these up. If we're going to double the amount of subintervals, we're going to go by halves. So there's our first rectangle, second, third. Yeah, I know I'm going backwards here, like that. So each of these has a base of 1/2. The distance from here to here is 1/2, there to there is 1/2, there to there is 1/2. However, their heights are based upon the function again. So we're going to do 1/2 times f of a half plus f of 1, f of 1 and 1/2, f of 2 plus f of 3.5, f of 4. All right. So, long story short, this now becomes 1/2 times 59, which equals 29.5. So before we got 34 with 4 subintervals. With 8 subintervals, we got 29.5. All right, actual area is 25 1/3. So again, 1 was too little, 1 is too much. It's like Goldilocks and the Three Bears. 1 was too hot, 1 was too cold. Eventually, we're going to find one that is just right. And the one that is just right would be our midpoint approximation, which is what we're going to talk about next.